In this next example, we've got y equals x minus 2 times x plus 5. We cannot differentiate until we have expanded this and collected any like terms. So using our simple rules of expansion, you should see that this is x squared minus plus 5x minus 2x is plus 3x. Minus 2 times 5 is minus 10. Oops. So then y dash is going to be, the 2 comes down as a factor, 2x to the power of 1, we don't write the 1, plus 3x simply derives to 3. Just to confirm, if y equals 3x, that's really 3x to the 1. So y dash is going to be 1 times 3 is 3, x to the power of 1 minus 1 is 0. 3x to the power of 0 is just 3 because that is equal to 1. So when x equals 2, y dash equals 2 times 2, which is 4, plus 3, which is 7. So the slope of the tangent to that function at x equals 2 is 7. All right, this one's a little bit chunkier and chewier, and you might need to review your index laws to do this one. Before we do anything, we have to get all of our x's into the numerator, and we have to get them out from under the square root signs. If you go back to the reminder of the index laws, then you will see how to handle our roots. So when we've got anything under a square root, so you might need to revise those. All right, so first of all, we're going to rewrite f of x, just f of x, as 3. Now 3 root x is 3x to the power of a half plus 5 on x squared times x to the power of a half minus 4 x to the minus 1. I'm just going to move that straight up into the numerator, which gives us 3x to the power of a half plus 5. Now this denominator becomes x to the power of 2.5, which is, so 5 on x squared times x to the half is equal to 5 on x to the 2.5, which is equal to 5 on x to the 5 halves, which is equal to 5x to the minus 5 halves. So that's how that is happening. If you need to, you can do that over in your margin or on a piece of scrap paper and then put the result in the line of working for x to the minus 1. Can I strongly recommend that you use in your indices as improper fractions rather than mixed numbers? They're just easier to work with when you're doing this kind of calculus. All right, so from there, all of our x's are in the numerator. They're all out from under the square root sign, so now we can take the derivative. So f dash of x is, now 3 times a half is 3 halves, and I'm just going to leave it like that. And this is going to be x. A half decreased by 1 is minus a half. So 3x to the minus a half on 2 plus 5 times minus 5 on 2. So in actual fact, it's going to be minus 25 on 2x. Now, minus 5 on 2 decreased by 1 is minus 7 on 2. Make sure you're convinced of that. Then minus 1 by minus 4 is plus 4. X to the power of minus 1, the power decreases by 1 to give us x to the minus 2. Be very, very careful when you are decreasing your index. When the index is negative, if you decrease it, it gets further away from 0, not closer to 0. Now from there, you can actually leave it like that. There is no need to simplify it any further. If these fractions, oops, wrong one. If these fractions could be simplified, then we would, but they can't, so we can just leave it as it is. As far as SACE is concerned, that is a perfectly valid answer. All right, in the next example, I'll do the displacement time calculations.